Okay, because Babylonian used that positional system, they actually developed much more advanced forms of formulas and equations like that. And one of them is that kind of solving quadratic equations. And remember, they didn't know about quadratic formula whatsoever. Okay, so for them, like some amount square, we can kind of translate like that, and that amount is multiplied some number is equal to certain amount like that. That kind of question looks totally different, like that square of certain amount is same as this, right? For us, they are the same question, right? But for them, they have to kind of develop different formulas. Eventually, it becomes very similar to each other, but in the beginning, right, they have to approach totally different way. Okay? But anyway, their formula for first type, like whenever we have that, and of course, in this case, it's more practical situation, right? So all the question they are interesting about is calculating certain amount of how many ships certain people has or something like that, right? So the numbers they use is positive numbers. So the hidden condition here is AB's, those numbers should be positive. And at the same time, the result, so the initial amount for x should be also positive, right? What is the meaning of having negative 2 ships, okay? Or 3 rabbits, negative 3 rabbits, right? No meanings of it. So for those type of quadratic equation, we expecting sometimes negative numbers, right? And even imaginary later, but they didn't think about it. So when they calculate, they only accept positive numbers for that. Okay, please remember that. Okay. So first thing, okay, how they got this formula, right? That might be interesting, right, for us. So we can kind of prove how they got that way, right? Who knows why how they did that, right? But we can prove that things, right? So let's say we have this given equation, okay, and try to get the answer for that is this, and they have that one as the result, right? So they didn't actually calculate it. They only have a formula. By the formula, they got the answer right away. Okay? So let's just try to figure out how they got that one. So from x squared plus ax plus b, oh, I'm getting used to the quadratic equation. So equals b in that case. Then they actually try to make complete square form for this one. Okay? So now, how can you get the complete square form? Okay, so x squared plus ax. Okay, then remember this way, uh, because to make the complete square form, eventually we are going to get x plus a over 2 and make it square. Okay? Remember that way, right? So hint is, whenever you need to make a complete square form of x cubed plus ax, take the half of it. Later, right now, our assumption is a is positive, but no matter whether it's positive or negative, just take the half of it, right? So if it's a negative 3, then you just put negative 3 over 2 here, okay? No matter what. But of course, we know the equality is not standard at this moment, right? We need some extra constant term to make it, right? And that constant term is actually, we can get here, right? When you pulled out this complete square form, that constant term becomes a squared over 4, or a over 2 squared, right? Okay, so because when you pulled out this one, x squared plus 2 a over 2x, right? Plus a over 2 squared. That's what we are going to get, right? So when you look at it, after cancel out these two, we have x squared plus ax, okay? And a over 2 squared, right? Okay, so that's the hint. That's why we want to get half of it, right? That's matching, exactly matching. But to get that one, we need to add a over 2 squared, right? Because of that. But this is the only given one. So we have to subtract exactly same ones over here, right? Okay, so all together from here we can get x plus a over 2 squared. So this much becomes that entire square form, and we have to subtract a over 2 squared. So that's how we got the complete square form of that, right? So that must be same as b. Then because of negative, we can add the same amount on both sides. Then it becomes equals b plus a over 2 squared. Then another algebra we know is something square equals triangle. Then that square is plus minus square root of that, right? Don't forget that. We need plus minus. So x plus a over 2, that's the square part, right? Equals plus minus square root of b plus a over 2 squared. But we only accepting positive square at this moment. In that time era, it's only positive square root of b plus a over 2 squared, right? So let me just delete this one. So from there, you can say x equals square root of b plus a over 2 squared minus a over 2, right? Or we can say that is x equals square root of a over 2 squared plus b minus a over 2. That's the formula, right? Then the remaining question is, what is going to be the formula for x squared equals ax plus b, right? And at this moment, the only difference is if you place this ax on the left-hand side, then we got x squared minus ax equals b, right? So for this complete square form, no matter whether a is positive or negative, it becomes positive there. So it doesn't change at all for that. The only change is that operation, because a comes with negative, so it makes positive. So for that case, the formula for x is same radical form, a over 2 squared plus b, and it's plus a over 2. Okay? So remember that whether ax is on the left hand side with x squared, then we have negative there. But ax is on the right hand side with constant term b, then we are going to have plus. Okay, we are not going to have any example about it, okay, to prove it, because just we know how to get that one, okay, so that much is enough. More practical case in the Babylonian era is like they really want to calculate semi-perimeter, like the half circle style, or the area of a rectangle. And most likely, we are familiar with this type of equation, right? The system of equation like x plus y equals a and xy equals b, and looking for what xy's are, okay? And we have the kind of substitution method like that, right? But they didn't have that much. But some clever guy figured out this method. So let's assume x equals a over 2 plus z for some unknown number. And let's say y is same a over 2 and minus z. Simply, the reason for that is when we adding this x and y, it should be a, right? But we know the most kind of simplest result for that is what? X, Y, both of them becomes a over 2, right? Half of it, right? They just shared. But we don't know. Okay? So X might be, we know that's kind of a mean of that, right? So let's say X is some value which is greater than that mean, right? And Y is from the mean, subtract exact same amount, right? So when we add these two, it's always A, right? A over 2 plus A over 2, and this something portion is cancelled out each other because of plus minus, right? So it's kind of very reasonable assumption like that. Then the only question is, these two numbers must satisfy this second condition, right? So let's just multiply them, okay? Then it's easy to catch out that z, right? When you look at the left-hand side of it, this form looks like a plus b times a minus b. In algebra, we know that is a squared minus b squared, right? So this left-hand side is a over 2 squared minus z squared equals b. So z squared is same as a over 2 squared minus b. Then square means what? Take the radical form, right? Square root of it. So we can get z easily, and of course it should be plus minus, if we only set negative, okay? I am the positive, then we can get what x, y is. Okay? So that's the entire style. So let's just use this example and try to use Babylonian method to calculate this. So it says, find the length and width of a rectangle with a semiperimeter of 13 and the area of 13. Okay? So we have a rectangle, and semiperimeter is what? Let's say width is x and length is y, whatever. So actual perimeter is 2x and 2y, right? So perimeter of 13 means just x plus y equals 13. The area is x times y is 30, right? So after you translate it, I mean, it's exactly the same condition like we have in front, right? Okay, so what was the method? We just simply put x equals the half of the a plus certain amount, right? Whatever it is. Then y must be from that mean value, half of 13, minus exact same amount. So when we add them, we got 13. Okay, then apply this one to the second equation. So 30, let me write down that one first, is x times y, which is 13 over 2 plus z times 13 over 2 minus z, which is 13 over 2 squared minus z squared. Therefore, z squared is 13 over 2 squared minus 30, right? So it's 169 over 4. And to get the calculation, let me get the same denominator, then it should be 120 over 4, right? So altogether, it's 49 over 4, right? Then it's actually 7/2 squared, right? Same value, so which means z must be plus minus 7/2, but we're only thinking about positive cases, right? So it's going to be 7/2 or 3.5, but let me just keep that way. So by that, x equals 13/2 plus 7/2. So it's 20 over 2, which is 10. And y is 13 over 2 minus 7 over 2. So it's going to be 6 over 2, which is 3. And whenever you do any system of equation, after you got the answer, please check, right? So adding these two is 13 and multiplying these two is 30. Okay, so we got the right answer. Now, actually they go further, and who says this is the only cases, right? Adding two values is 13 and multiplying their numbers is another number. How about subtraction between those two numbers, right? The difference between two numbers is a certain amount and multiplication is another amount. So we can translate that one like this, right? X minus y equals A and xy equals B. So second equation is same as before, but the first equation used negative, okay, instead of addition. So in this case, the only difference is kind of replacing the positions, right? In the previous case, x equals a over 2 plus z, y equals a over 2 minus z. But in this case, if original function or the equation has x minus y, then you have to kind of convert the position of these two places. Okay? And eventually we get the result. But before doing that, let's just check why we need this one. If we subtract x minus y, x is z plus a over 2 minus z minus a over 2. Now you see the reason for that, right? Using minus, we want to get a, right? So if one of them has a over 2, the other one, especially for minus, right, should have minus a over 2 to get a. And those ones adding and actually subtracting because of this minus, right? So we got always a by 10. So be careful. In this case, we don't have any freedom, but the variable comes with minus in front of it, should have minus a over 2, right? But after that, everything is just same meanings and same format. So let's just practice with this. Okay, this is just a modern way of writing, right? Maybe they say, oh, someone has that and minus certain amount is 12, like that, right? So let's just change a little bit and extend the condition. It's not simply just xy equals some amount, but xy plus x plus y equals 588. So in this case, because the previous one, you're just using it, right? So this case is so simple, so it's kind of extension of that, okay? So hint for this one is we have to start with some another extra substitution. So let y equals z minus 2. Okay? Don't ask me why, just try to solve it and you can see how it's going to work. Okay? So simply the form is looks like that. Okay? That's all. Then because of that, x minus y is same as x minus z minus 2, which is x minus z plus 2. And we know x minus y equals 12, right? So we can put equals 12 for that. So finally, we have x minus z equals 10. And let's apply same setting for the second equation. So that's the first case. And second case is from xy plus x plus y, we got x times z minus 2 plus x plus z minus 2, right? Replacing all y's by z minus 2. And let's simplify that. Xz minus 2x plus x plus z minus 2. Then it's xz minus x plus z minus 2. Then we can have xz minus x minus z, right? Minus 2. Then by that, we can change that one to 10, right? So it's xz minus 10 minus 2. So xz minus 12 equals, that is 588, right? So altogether, we got xz equals 600, right? So when you have this, actually what we got is this two result, right? So this question is changed to some system of equation about x and z, not x and y anymore. But we know the relation between y and z, so we can get the y value later if we get the value for z. So let's change our goal, right? Now our setting is x minus z equals 10 and xz equals 600. Now this setting is the case that we just covered here, right? Because x minus z. So don't be confused about y and z, right? It's no meaning, right? So we want to put x equals, now in that formula we use z minus a over 2 or something like that, right? But now we already use z, so we have to use something else. So let me use just t temporarily. So the first one is plus a over 2. Why? Because z comes with negative, so z should have negative 10 over 2, right? So z equals t minus 10 over 2, right? We have to keep it that way. So we already checked, when we add these two, subtracting these two, we will get 10, right? That's how we setting like this one. So we don't need to check the first case. So we just go to that one. Okay. Then that 600 is x times z, which is t plus 10 over 2. Let me change it. It's 5, right? And z is t minus 10 over 2, which is t minus 5. So it's very simple. It's t squared minus 25, right? So adding 25 on both sides, then we have t squared equals 625, which is 25 squared. Therefore, t must be plus minus, of course, square root of 25 squared, but it's plus minus 25. But once again, we only thinking about positive cases. So t should be 25. Then put this one into that setting. Then x must be 25 plus 5, and z equals 25 minus 5. So x must be 30, and z equals 20. Ooh, we got the answer, right? But remember that there is no happiness in math world. So whenever we think we got the answer, be careful, okay? Just check what you're looking for. And actually, we're looking for the values of x and y's, right? Not x and z. So you have to somehow to find out the values for y, which is z minus 2. So finally, x is still 30, of course, but y should be 20 minus 2, which is 18. And of course, please check with that, right? 30 minus 18 is 12, right? And 30 times 18 plus 30 plus 18, right? To calculate those and to check if you get 588 for that, okay?